Hey.
Seven's not working?
No. Today it's my turn. Hello, everybody. Welcome. MSDOSX Lecture 3. Yes, not off by one. So, today we're going to be doing the first of two parts of memory management and collections. One of my favorite topics. When people first start off with Objective-C and they learn how memory management works, people either love it, think it's the greatest thing since sliced bread, or they despise it. And most people despise it initially because it's very different than probably what you're used to. A lot of people are used to either the C and C++ model, where you have ultimate control over memory management and allocating and deallocating memory.
Can we stop talking, please?
You have ultimate control over memory management and exactly when memory is being allocated and released, all the way to the other end of the spectrum with Java, where you're not worried about memory management, at least initially, on the surface, where you're just allowing it to take care of all the garbage collection for you. So Objective-C uses a memory management model that we're going to talk about in here in a second. That's more in between. It gives you some control, but also gets rid of some of the nitty-gritty details and some of the helps alleviate some of the bugs, some of the really common bugs that happen in C and C++ programming. So, first thing that we're going to talk about are collections. These are ubiquitous in iOS and OS X programming. Ways to store and hold globs of memory and information. The most common one, the one that's easily transferable mentally, model-wise, between different languages, is the array. The Objective-C class is called NSArray. It's a list of objects, and they are in order. They're indexable in order. Here's what the method call is, the message for accessing an element in the array. Remember, the syntax is bracketed, the target is on the left, and the message is on the right. So this collection here, starting off with array index 0, the target is array, and its object at index is the message. Object at index 0 will give you this object back that's been stored in the NSArray. Object at index 3 will give you this index back. Counting starts at 0, not at 1. That's pretty straightforward. NSSet is the other collection type. It is a collection of objects that are not in any order. You are not, if you add a bunch of objects to an NSSet, you're not guaranteed to get the same objects back out in the exact same order. So what you use instead is more akin to a key-value pair, and we'll talk more about these later when we start talking about dictionaries. But the message, the primary message for getting an object out of a set, here again, set is our target. The message is contains object, and then you pass in a pointer to an object, and it returns you back a Boolean value of whether or not that object exists in the set. NSCounted set is just like a set, except it allows duplicates. NSSet, if you add a duplicate object, it's ignored. NSCounted sets allows you to add duplicate objects, and what's handy about this is that you can add a whole bunch of objects that you may be using, and which you'll see later on too, the importance of it, and be able to find out exactly how many of those, a count of those objects within the set. Same thing, counted set is the target. The message is count for object. You pass an object pointer, and it'll tell you how many of those objects exist in that set. Cool? So, NS Dictionary, key-value pairs, very, very common in all languages. It consists of two objects. The object on the left is the key. The object on the right is the value. The key can be, excuse me, made up of anything that is subclass of an NS object, meaning it can be any type of object. It doesn't mean primitive types, and we'll talk about some of that a little bit later on too. But for now, even NS strings can be keys, which is very, very common. The way you pull a value out for a key value pair is dictionary is the target. This is an instance of a dictionary, just like these other ones were instances of counted sets and instances of sets. Object for key is the parameter. You pass in the key object, and it will return you back the object that's associated, the value of the object that's associated with that key. Make sense? Cool. So, if this is your dictionary, and let's say we're going to draw an analogy here to an actual dictionary entry. We're going to use Coco, and if you ask for, you can ask for the key value pair, like I had said, using a string. Remember, the string literal is an @ sign surrounded by quotes around the text, and you ask for an object for a key, and you get the value back. And in this case, the value is this dictionary entry. So, mutability. For reasons of efficiency, which should be pretty obvious to people that have used multiple languages that have mutable and immutable types, especially Python and Scheme. Immutable is the default. Objects are created once, and you can't change their contents. You can create a collection of mutable objects. The way that you do that is just simply inserting the keyword mutable in between NS and the collection type. So, for instance, NS counted set is a collection of immutable. It's an immutable collection of objects. NS mutable counted set is a mutable collection of objects. You can convert, quote unquote, convert a immutable set or collection into, sorry, not an immutable set. You can convert an immutable collection into a mutable collection by using mutable copy. Mutable copy is the message that you pass to the immutable collection, and you get back a copy of a mutable collection. Does that make sense? So in this case, if we did dictionary mutable copy, we'd get back we would get back an NS mutable dictionary that has key value pairs that can be changed.
So it works just like the regular copy method, which just takes an object and returns a copy of it, but in addition to making it a copy, it makes it mutable as well.
So have you guys seen the copy, have you seen or used the copy method yet, or copy message for object types, for any object? Every object comes off of NS object has got a copy message or copy method. Yeah. For the time being, we're gonna say that they all have copy methods and messages, and but they return you back a copy and a mutable copy. Using the mutable copy message will give you back a version that you can change on the fly, dynamic. So there's a couple of different methods then for mutable collections. Obviously, if you have an immutable collection, you can't add or remove objects from them. Now, if we're using a mutable collection, we've got some additional methods. For instance, an NS mutable array has got an add object message. It takes in you start with the target is the array, the message is add object, and you pass an object in, and it'll add that object to that array. NS mutable dictionary has got set object for key is the message, dictionary is the target, set object, and this is your value for key of your key value pair. And there's a, like all other NS classes, there's a ton of documentation in the Apple developer docs that's part of Xcode 3 and online. So one of the conveniences of having a collection are having innumerable types that you can access elements of a collection in a very abstract sort of way. So it works. You can change the underlying collection, and your enumeration. The enumeration logic stays the same. The way that you get an enumerator for a collection is using the object enumerator message. So NS enumerator is what do I want to use? That's the generic type for an enumerator, and of course it's a pointer, just like all the other NS object, anything in Objective-C, all of the classes, all the instances are always pointers, right? Collection is this is our target object is a collection, whether it's a set, an array, or a dictionary, and object enumerator is the message that will return us back an NS enumerator pointer. Then this is this is a couple of expressions mashed into one. I like to pull these apart, be more verbose about them, but we'll go inside out. So we just declared we're going to say that this collection is full of my objects, whether that's the parent class or it's a subclass of my object, and calling enumerator next object, calling it over and over again will get us the next object in a collection, whether that's a key value pair, a key.
In a dictionary, it goes through the keys.
In a dictionary, it'll go through the keys. In an array, it'll go in order. In a set, it will give you back some ordering of all of the elements that are in there. In a counted set, it'll give you some order of all of the elements, which can include duplicate elements. And every time you call next object, it will return you back a pointer to either one of the objects that exists in the collection or null, nil.
Yeah, we'll give you back nil when there's no more elements left.
When it's all done enumerating over the set, it'll come back with nil. So this is the kind of the old verbose way to do it. Objective-C, was it in 2?
It's since 10.5, I believe.
Okay. Since 10.5, there's a new syntax for loops that go through a set of objects. Here's what it looks like. You can access every element in a collection very, very quickly. It's a for loop, and the syntax is the class type pointer and the variable that's going to contain the objects that come out of the enumeration in, and then the name of your collection instance.
If you're a Java or a Python person, this should look really familiar.
Right, right. If you use the fast enumerator. Inside of here, my object will continue to be updated with every element in the collection until it's finished, and then the for drops out. Apple highly, 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 highly recommends that you don't ever subclass collections. We're going to learn a little bit later on how you can add functionality to a collection if you need to, but don't ever.
You can do it if you want.
If you want,
the explanation is basically you don't need to.
Right. They're really if you find that you have to, you're probably doing something wrong. So it's probably a good idea to get a second opinion before actually going ahead and doing it. The recommended way of doing it is just like in C++ an ISA versus HASA relationship. You've got we're going to just use a generic type for an NS object for a generic parent class NS object, and then have it contain an array, as opposed to subclassing off of an array. Once you use this more in practice, you'll see times where you'll think, oh, it might be convenient to subclass a collection type. Keep this in mind. Use this, and it should, as you're writing more and more collection routines that use collections, this will make a lot more sense to you. Just for now, just remember the guideline is don't ever subclass a collection like that. Very little that. This is what the Apple documentation says directly about subclassing a collection. The class does well what it is designed to do, which is very true. So part of Cocoa are the foundation classes. Here's some really, really helpful foundation classes that are part of Cocoa. NSString you've used before. You've used some subsets of the functionality before. There is an enormous number of methods that NSString supports. The real typical common ones are the class method string with format, where you pass in a format string and you get back an immutable NSString. NSString instance, and then there is, if you've got an NSString allocated already, there's a knit with format. It's the same thing as string with format, except you get instead of getting a copy back, you use the one that you already have. There's lowercase string is a message that you can pass to an NSString, and it'll change all the characters to lowercase. You can get the length of the string with the length message. Then the way to use numbers, in particular numbers, as keys for dictionaries is very typically they're either turned into strings, or you'll see later on that there's also some NS objects that represent integers and floating point numbers. But if you've got a string a string of digits that represent a value, an integer value, a floating point value, you can convert it to a native type with int value, float value, double value, bool value, and unsigned value. There's a number of these. The documentation lists all of the conversions from a string of digits into an actual native number. Then is equal to string, very, very common one to test the equality of strings character by character, not pointer to pointer. Substring to index will give you back a slice of a string. Will give you back a substring. There is the range of string. I got this backwards last time.
Range of string is if you're looking for a substring in a string, it'll give you back an NS range telling you where in that string, where in the receiver string the parameter string appears.
That's right. So searching for a substring within a string, NS range gives you back the start and the length of where it found the substring, if it found one. And then has prefix is also a really common one, especially if you're doing file manipulation and directory and file manipulation to look for file extensions. This just tells you if a string contains the last few characters of a string contain some. This is like a substring at the end. If it ends with a certain string.
Would that be suffix?
Prefix is at the beginning. There also is a has suffix.
Oh, yeah, read that wrong. You're right. Good catch. We should add has suffix just so I can remember that. So NS number is this is the way that you wrap native types, native numbers into objects that can be used for keys or for any other messages that require objects as parameters. Number with so it's number with and then the type. Some of the class methods for NS number are like number with int. So you give it it's NS number with int. You give it a raw integer, a native integer value, and you'll get back an NS number that represents that integer value as an NS object or as an NS number. Number with double, and then if you've already got an NS number allocated, there's initialize with float, initialize with a Boolean, there's initialize with unsigned, there's a ton of them, also in the documentation. And then you can get the native values back out of the object with type and then value, like char value, float value, int value. These are really common. These are also toll-free bridged, I believe.
So if you're familiar with Java and you're probably used to the capital integer class, which is used for boxing and unboxing the primitive int type, that's actually rather expensive in Java. In Objective-C, NS number is not an expensive class to use to do those transformations between primitive types and the object type. So feel free to freely use them. They're rather efficient.
Yeah, they're incredibly. There's very, very little overhead in using these. If you want to use integers or floating point values or unsigned integers as, say, keys to dictionaries, or you need to pass them around, don't be afraid to use these since they are incredibly efficient and there's very little overhead. NS dates is also a really popular and common class to use. It's just one single point in time. There's date ranges. What is that class?
The calendar class?
NS calendars that has NS calendar is a class that has ranges. NS date represents a single point in time. Some of the class methods: date with time interval since now, and you can pass in a number of seconds, and it'll give you back a date that is a number of seconds into the future. Then there's if you have some kind of timeout, or you've got some kind of loop that you don't necessarily want to terminate until another condition, and you're keying off of a date. They have distant future and distant past, which are defined as...
They're basically plus infinity, minus infinity for dates.
Right, so it's a date far, far into the future so you can use it as, say, a placeholder for a date that hasn't yet been set. It's useful for debugging as well as you'll see it used in some conditional and looping constructs. And then there's date by adding a time interval, which is like date with time interval since now, except this is using a current date that you've already allocated and that you may have, say, a date for next week and you want to add 60 seconds to it. This is the method that you would use, by adding a time interval. And then there are date comparison functions that are very efficient ways to compare two dates and whether a date is equal to, before, than, or after another date, chronologically speaking. Memory management. Okay, so here's where you should focus. Take a deep breath and focus on this. And since we have two labs that you're going to be working a lot with this. So if you don't understand it 100% as I'm going through it, please ask. If you still don't understand it, try your hand at the lab, and if the questions still come up, please feel free to ask us again. This is typically a pretty tricky subject. Some people believe, oh, it goes away with the new automatic reference counting.
We still feel that in order to understand how automatic reference counting works, you have to know the rules of how to do proper memory management.
And there's actually a lot of issues that you have to take into consideration, and the only way to make a really good judgment call on automatic reference counting and optimization and debugging is to really kind of understand how memory management works. So, if you're talking, please stop, and because this is really important, especially even for the people that are in the back to focus on, because this is usually a topic that's really pretty tricky to understand. So, here we go. So, in C, you have malloc and free, right? That's your tool and your hammer and chisel in C for allocating and freeing memory. Java uses garbage collection, where you don't explicitly have, You have to allocate things, but you don't explicitly have to deallocate them. It's done for you by a garbage collection. Now you're going to understand a little bit about how that process actually works in Java. And if you've ever written a big Java project and you've started to have problems with memory, but it's pretty much out of your hands, this is the remedy for it. So Objective-C uses a process called reference counting for their memory management. Every object, every single NS object has got a reference count associated with it. And this is one of the big reasons that every single NS object is a pointer. Always, 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 all the time. Because you need to have stored always a reference count to that object. And we'll talk about what that is and what that's used for in a moment. So when you call alloc, the class method alloc, which is available for every NS object, when you call alloc or you call copy, the reference count of that object is set to 1. Okay? You use the messages retain and release to add or subtract 1 from the reference count. Okay, so you allocate it, it's 1. You call retain, it's 2. You call release, it's 1. You call release again, it's 0. Okay, seems pretty straightforward. Cocoa doesn't actually get rid of the memory until the reference count reaches 0. This actually happens in Java as well under the hood. It's keeping track of who has access to who. And when nobody's touching or has access to a block of memory, an object, it gets rid of it. Now you'll be dealing with it in a more immediate, hands-on way. Allocate sets it to 1. Copy sets it to 1. Retain increments it by 1. Release decrements it by 1. It doesn't get deallocated until the reference count reaches 0. Okay? So, here are the rules. Allocate 1. Allocate memory, set the reference count to 1. Copy, allocate, make a copy of an object's contents, set the reference count to 1. Retain, increase the reference count by 1. Release, decrement the reference count by 1. Every alloc or copy or retain has to be balanced with a release, which makes sense, right? Because Cocoa doesn't actually free up memory until the reference count has gone to 0. So alloc, copy, retain always have to be paired up with the release. Oops, am I going backwards? Yes. So, standard object allocation. This is boilerplate code. Allocate sets the reference count to 1. Init. What does init do? What does it do to the reference count?
Nothing.
Nothing. Nothing. All right? Allocate sets it to 1. Yes. If you use new,
You can't use new
Don't-
on Objective-C objects.
yeah. Yeah, don't do that. You can use new if you're using C++ objects. That's fine. But any NS objects, anything that's NS object or subclass of NS object, you have to use allocate or copy, or one of the class factory methods, and we'll talk about that in a second. You do a whole bunch of stuff with an object, and then you want to get rid of it. Release, just once, brings the reference count to
Down 1.
0, which Cocoa will release the object. Same thing for copy. Here we've got an object, other object that's been allocated already, has had some values filled in with it. Do a copy. We get back a copy of the object. The reference count is 1. bunch of code paired with release, because what gets paired with release? Copy, alloc, retain. Let's say that you've got an object called controller. Doesn't matter what the class is, and you call it with this message myObject, and it gives you back a pointer to an object. Was it alloced? Was it copied, or was it retained? No. And you don't need to know. And that's actually the beauty of this scheme. And we'll see later on where this really comes into play. So it doesn't matter what the reference count is. You didn't allocate it, you didn't copy it, and you didn't retain it. So you don't release it. Okay? If you need to be sure that that object sticks around, because maybe you call this controller myObject method, and you get an object back from it, and you want to do something with that object. You need values out of it. You need to store some values in it. If you need to be sure that the object is not going to get released out from underneath you, you call retain. What does retain do? Increase the reference count by 1. So it doesn't matter what controller's done with this object that it's returned, what its retain count is, doesn't matter to you. Could be 0, could be 1,000, doesn't matter. We want to be sure that the object sticks around, so we call retain on it. When you do that, it increments it by 1. Then no matter what my controller does to the object, it could, if it's balanced, if it has balanced release calls, then as long as you've got a retain count incremented on it, it's not going to get released out from underneath you. Work some code with the object, then release it. Balanced, retain and release, 1 and 1. Compare this to C, where you've got malloc and free with no reference counting. And a function allocates an object, gives it back to you, you free it, then the function frees it. Happens all the time in large C and C++ projects. All the time. This obviates the need for that. It doesn't matter what this object comes back with its retain count. You increase the retain count, it's going to stick around. You call release, say, I'm done with it, then you don't care, right? It could be released now, or it could be released later on. You just have you've let Objective-C know, I need my object within this body of code. So, mirroring the retain, let's say you get an object back, you're going to make a copy of it because you don't want to modify the original object, but you do want to modify a copy of the object. You need it for something. You make a copy of the object. You don't need to retain the original object. You've got a copy of it, right? But the copy does what? Sets the reference count to 1 of this object, right? We use object and then we release it. Balanced. 1 copy, 1 release. Yes?
If you didn't need to, how do you know it's not, the object isn't going to be released before you can copy it?
That's a really good question. Hold on to that. And if I don't address that, bring it back up again.
The short answer is it's because of the stack. As long as it's on the stack, it will still be there.
Right. And the run loop, and we'll talk about that in a second. So, here's a yes. Sorry.
Can you explain what the differences between doing copy and doing retain? So, when you're copying it.
Yeah. So retain means the original object. Take the original object that I was given back, or the original object that I'm messing with. I need to hang on to this, and I'm gonna mess with this object. So make sure that it doesn't go away. Right. So it's like locking the object down, messing with it, and then saying, okay, I'm done messing with it, right? So copy, on the other hand, says, all right, I've got this object. I don't want to mess with it, or it's immutable, right? And we want a mutable copy that we can mess with. So we make a mutable copy of it. That original object stays alone. We don't care. It could go away, whatever. We've got our own copy of it. Its reference count is 1, so it's not going away until we actually release it. Does that make sense? Okay. So here's the analogy, the graphical analogy of it. We've got a dog, and we allocate the dog, and we initialize the dog.
So we put a leash on the dog.
Yeah, exactly. So this allocate, reference count is 1. So we got a leash on the dog, right? We call Fido is the name of our instance of our dog. We call retain on Fido. We put another leash on the dog. Its reference count is 2, right? We say Fido release here in the code. These can be 2 separate pieces of code. These can be 2 separate machines. We've got a leash here, and we release this leash. This leash stays on. We call it retain. Fido's not going anywhere, right? We called retain. It's not going anywhere until we call release. Call release, drop the leash, Fido goes away. Cool. Go. So, yes.
Just one question. So when the reference count is 0, is there any sort of method that object will call?
We'll get there.
Yes. Hold that question as well. That's a really good question. And we're going to talk about that in just a second.
Yeah, this is like part related. When you call release and it is 0, does it have, does it vanish immediately, or is there time?
Hold that question too. Yes. Very good question. So, here's a common problem in computer science languages, especially when it comes to memory management. You have a function called make cool object, right? It's, say, a factory method. And you call it, and it allocates and initializes an object and returns it back to the caller. Who's responsible for freeing it? It's up to the API, right? You could say, you could put in comments, okay, I'm allocating this, you're responsible for freeing this. This happens all the time in C. You're responsible for freeing this, or don't free this. I'm going to free it. I'm going to call an initialization and a shutdown method or function. So I'm going to give you back an object, but you're not allowed to free it. Don't free it. Which is a huge hassle and is really, really error prone. So the whole point of reference counting and garbage collecting is your method shouldn't need to release an object. If you create an object, the caller of your method shouldn't have to be responsible for memory management. So if you're a factory method and you create an object, the person who's using it shouldn't have to be responsible for who is supposed to be releasing the object. You're responsible for it. So any object that you own already, you can return it. If, say, you're writing a factory method, this is where it's commonly used. You can return it as long as you are responsible for releasing it later. So
if you have an instance variable in your class that's some say an array in your class, and you allocate it in your initializer, say, you can freely just return a reference to the object in any one of your methods as long as you release it at some point in the future.
So if let's say you're making a class called factory, right? And factory has new car. And you call your new car message allocates and initializes a car and returns it back to the caller, right? So allocate does what? Reference count is 1, right? So it goes out to the caller. The caller is not responsible for releasing it. If the caller needs it, it does what? Calls retain on it. Then the caller is responsible for what? Calling release on it before finishing, right? Because You need that. The reference count ultimately needs to go to 0. But when the caller calls retain and release, what's the reference count? 1. You allocated it, you returned it. They called retain, it's 2. They called release, it's 1. It's still retained. It's still hanging out in memory. You, the factory, is responsible for deallocating it, which can lead to some interesting quandaries.
And go on the next slide, I think let's talk about it.
Right. So what happens if you're just a factory method, but you don't want to have to create another method later that says, okay, call me because I need to release all of the objects that I've allocated. So we can return back an instance variable. We don't want to return back a copy, right? Because if we return back a copy, then now we're going to be responsible for releasing both of them, right? Or we're going to be responsible for making sure that the object that we copied gets released, and who's responsible for the copy now, right? Very confusing. So in comes auto release. So here's what we're trying to do. We're trying to write a method that takes a string and returns back a copy of a string, right? We don't want to do this. We don't want to make a copy of it because now there's 2 objects that might have that has one has a retain count of 1, the copy. One has some unknown retain count. So how do we do this? How do we return this back, and how are we good citizens and responsible for making sure that the memory is all cleaned up?
And notice also that this is a class method, so we can't just say it's an instance variable and then release it later.
Good call. So this is a NSString class method, and NSString allocate, our standard allocator, initialize it with another string. What's the reference count that's returned? The object that's the NS string that's returned, the reference count is 1.
So that won't work.
That's not going to work, right? Because at some point, somehow later, we need to get that reference count back down to 0 again. We don't want to provide another class method that says, okay, release this string now, right? Super redundant, unnecessary. The only way that this can go down to 0 is if the caller calls release on it, right? That's the only way it's going to happen. Otherwise, we have to provide another method that releases it. The caller is now responsible. We don't want to do that. We want to get away from that. So, how about this? Allocate it, release it, return it. It's probably not a good idea, right? Should be real clear, especially C programmers. Free it, malloc it, free it, return it. Yeah, it's not going to work so good, right? So, in comes auto release. This is the part that people struggle the most with. I'm going to try and demystify some of it here, and it's also, you're going to get a ton of practice with it in the second lab. You're going to get a second lab. You'll have a ton of practice with auto release. You'll actually even be writing your own auto release too, just so it can take some of the voodoo and magic out of it. When people first learned about this, including myself, I thought this is way too voodoo, black magic. I hate it. It really bothers me because it seems so non-determinate. Here's what we use. We allocate it and initialize it just as normal. The reference count is 1. Then we call auto release. It's a memory management message that NS objects have: retain, release, and auto release. Then we return the string. Auto release releases it sometime later, and this is the part that people have the most trouble with. And I still get a few bugs caught on this every once in a while. You can return it without, and it's not going to have been deallocated like you had just called a release on it, but it will be released sometime later. If the caller needs to use it and wants it to hang around, what does the caller do? Retain. Retains it. The reference count goes to 1, uses it. The caller calls. They've retained it. Release. Always balance retainer with the release. And it will be released sometime later. You're giving up responsibility here at this point. When you call auto release, you're saying, I know this will be released later. If my caller needs it, they'll call retain on it and then release it later. But I'm no longer responsible for it. So let's peek a little bit under the hood so this doesn't seem like such magic. So every time Coco calls your code, and this means when you're in the when at the beginning of the run loop of your program, whether it's an OSX application or an iOS application, on entry of your program, and this doesn't mean when your program starts, this means every time your program is called by the system, it allocates what's called an NS auto release pool. That's a pool, it's a collection where objects that have been marked as auto release get put into. It's a set that set? Yes.
Yeah, I don't know. I think it's a set. It's not super important that the implementation, but
right. It's just know that it's a collection, and you're actually going to be doing this in the lab too. But it's a collection that the object gets added to. It's the pools can be stacked, so you don't have to do anything, and you call auto release, and it'll go in the exact same pool. And you just call auto release on objects, and they get thrown in the pool, thrown in the pool, thrown in the pool. They don't get released right away, but they get thrown into the pool. If your caller or callers need that object, they'll call retain and release, and the objects stay in the pool. When the pool is deallocated, all of the objects within it get released. The pools can be stacked, like I said too. So you'll automatically have a pool that's allocated on entry of your program. You can create additional pools, and there's reasons for doing this, mostly optimization reasons.
Also, if you're running a multi-threaded program, you need to make your own pools.
Right. So multi-threaded programs, the main thread will have its own auto-release pool. Any additional threads you create, you need to create auto-release pools for those threads. And you're going to get practice doing this. So if you don't, still kind of gray and hazy for you, don't panic, because you're going to get practice with this. So every new auto-release pool you create, when you call auto-release on an object, it will be added to the most recently created pool. So it's like a stack of pools. The first one, your main one, that's always allocated, whether you do anything or not. Then if you allocate a new pool, all new objects will go into the last allocated pool. Now, auto-released objects will go into the last allocated pool. When that pool is released, and that pool goes away, all of the objects within the pool get released. So it's a way to delay the release. This pool gets deleted when when it leaves the run loop of your program. This means as the system is calling your program in the run loop, and we're going to see.
And it does that very fast.
Right. It comes in, creates the pool, runs a section of your code until the multitasker pulls you out and releases the pool. So the call chain, as you are creating objects or as you're calling methods and creating objects and, say, auto-releasing objects, they're going to stick around until the call returns from the current stack frame. So calling auto-release doesn't mean now the stopwatch is running, and you have to, in a certain period of time, you have to make sure you call retain, or the object goes away. It's much more disciplined and structured than that. It is as the calls are being made and the call chain is going down and then coming back up again. The objects will stay in the auto release pool until it comes all the way back up again, until it leaves your program, and we'll see a graphical version of that in a second. Then the pool gets drained. So the way that this works is every collection, when you add an object to it, its retain count gets incremented. So you have an array, you've got a whole bunch of objects. Let's say you've allocated them, which means the reference count is 1. You add the object to the collection, its reference count is now 2. Every time you add an object to a collection, its reference count gets incremented. When that collection gets released,
not released, deallocated.
Deallocated, sorry. When the collection actually gets deallocated, meaning that the collection's reference count has gone to 0 and it gets deallocated, every object gets release called on it. That doesn't mean every object gets freed in the collection. It means the reference count drops by 1. So, 4 objects, all allocated. Reference count 1, 2, 3, 4 on each of them. You add an object to add each of those objects to a collection. The reference counts will be 2, 3, 4, 5. When that collection gets deallocated, those reference counts go back to 1, 2, 3, 4. You're still responsible for it. You're still responsible for releasing those objects that you've added to the collection. The collection just ensures that by incrementing its reference count, calling retain on each object that gets added to it, the collection ensures that those objects won't get released out from underneath it. So dealloc is a method that's defined for every NS object. It's called automatically when the retain count reaches 0. It's very commonly overridden to provide additional cleanup when your object goes away. Like a common one is an object that has file descriptors in it. And you allocate the object and you open up some files, and those files are associated with the object. The file descriptors are instances within that object. When that object gets deallocated, meaning its reference count goes to 0, it's very typical to override the deallocate and make sure that those files are closed, or any other objects that your object has allocated releases those objects. Don't ever call it directly, ever, ever, ever. Don't call dealloc directly. If you want to get rid of an object, what do? Call release.
In fact, I'm pretty sure it's not even guaranteed to work correctly if you call dealloc directly.
So,
We kind of talked about that already.
yeah, I'm trying to see if there's anything different in there. We saw this. Okay, so you can take a look at this slide. This is just review of what I just talked about. You have objects that have instance variables of other objects. They have instance variables of other objects. You override the dealloc. You override the dealloc and release those objects that you have allocated or that you have retained, and any objects that reach their reference count goes to 0, their dealloc will be called, which will then release, and any that have gone to 0 will also release. So it's a really clean way to clean up after your objects. So here's typically what it looks like. Here's the method, and the message is dealloc. It returns, doesn't take any parameters, doesn't return anything. Here are objects that are instance variables, say that are part of our class, that are part of our instance. and we release them, we release them, release them. Then we want to make sure that our parent gets called, that our parent's dealloc gets called. This is the only legal place that you can call dealloc. All you're really doing is saying, okay, now it's safe for my parent to deallocate as well. Yeah. Okay, so very fundamental difference. Release drops a ref count. That's it. It decrements the reference count. When that reference count reaches 0, dealloc is called. So they're two very different things. When release, yes, exactly.
If you're working like with multiple auto-release pools, and you auto-release an object, and then you call retain, and then you call release, and you have a new auto-release pool at that time, does it get automatically added to the newest pool?
You are going to be doing almost exactly that in the second lab.
Okay.
You'll be messing with that. Questions. So, I know this was handled a bit third grader-ish. Yes.
You call an object, you call release on an object that's already been released, is it error?
Yeah.
That's going to be a problem.
Does it? But wait a minute. What's the reference count? If your reference count is 10 and you double release an object, you're fine. It's still there.
Well, I mean,
For
now, until whoever did those other Alex or copies or retains in the first place release it.
Well, what if
Right,
the
my point is, what if you retained it 8 different times or 10 different times through a call chain, and then you double released it? As long as you double retained it beforehand, whether directly or indirectly, you're still okay. If an object gets deallocated twice because a retain has been sent and the dealloc has been called, say, by the super, or 2 things simultaneously send a release, like if you have a multi-threaded, those are bad. And those, you'll either get a crash or you'll get zombie messages, and we're going to talk more about those later on. So it's just key, it's really important to remember that allocate.
If you Alex, then you need to release.
If you alloc,
then you need to release.
Right.
If you retain, then you need to release.
Alloc, copy, retain, all get balanced by a release. So it's valid to double release or quadruple release or 8-tuple release, right? As long as you had done, say an allocate and 7 retains along the way, right? But if you're unbalanced is where you start having problems. If you're overbalanced on retains, you're going to get a ton of leaks, where you're going to have a ton of memory that gets allocated and never gets released. If you have too many releases, or say you throw something in the auto release pool and then release it again yourself, you're going to start having zombie objects, or already objects that have been freed, and you're trying to send messages to them, like dealloc. Yeah.
Is there a way to get a reference count for an object, like if you lose track?
That's an excellent question, and that's exactly what you'll be doing in lab number 2.
Tuesday we'll talk about that.
Yeah. This one is asteroids,
The asteroids
right?
lab, which is very fun.
Yeah. So this is a fun lab. You'll be using the memory management system in a fun context with an asteroids game. And on Tuesday, we're going to dive a little deeper into this and understanding this, and the lab will get you very comfortable with reference counts and auto-release pools and debugging and all that fun stuff.
So apologies on the length of this one, but it is a very important thing to know how to do correctly.
And we'll talk more about if people still feel like, well, it's automatic replica counting. Why do we have to learn all this? We'll talk about that later.
I can mention it.
So in Java, if you've ever written a really big Java application, especially a Java application that uses a lot of data, and you start having huge class trees, right? And you start your Java program starts grinding to a halt. Almost always, that's because the garbage collector is making bad judgments on when it needs to release an object. And the way that Java make sure that it keeps track of objects that you've allocated and that they don't get released out from underneath you can be too conservative, where it's taken out of your hands, and it may say that the JVM may say, don't ever release an object ever until the program quits. It's perfectly valid for the JVM to do that. You typically don't have control over that. So what's key about the reference counted system is that you now have much more control over when objects get released and when objects, making sure that objects stick around that need to stick around. And having automatic reference counting is great, where you don't have to match these retains and releases, but it takes it out of your hands. And if you start having issues with memory management, and most often it manifests itself in having leaks or having really bad hitches in user interface response because the garbage collector is running, spinning pinwheel while it deallocates 50,000 objects that have collected in some pool of garbage collection objects. Not understanding what's going on under the hood is a killer. It can be really hard to debug and to figure out why you're having problems with memory management or the side effects, having really sluggish user interface response in particular, if you don't understand the memory management system to begin with in the first place. What's going on under the hood? Yeah.
So can Xcode display the heap? So what objects are currently
Yeah, in a sense, it can.
Can instruments do that?
Yeah. We'll talk about some of the debugging tools next time that are memory management related. And yes, you can take a really nice clean look at all the objects that are allocated, but it's a separate tool. That's if you use Xcode 4, it's part of the analysis package, the instruments package in Xcode 3.
You said that an auto release pool when it's reallocated releases all the objects.
Yes.
Does that mean like if an object has reference times 2, after you release the auto release pool, it's still on the object?
Correct. Doesn't go away. Yes. Which is exactly what you want to have happen, right? If we have the string with string, right, and we're turning back a copy, and the caller says retain this. I need to hang on to this copy. The string with string, the class method, has called auto release. It basically says I don't want anything to do with this. I don't want responsibility for it anymore. The caller says I need this. I need this to hang out. So it calls retain. Its reference count is 2. The auto release pool goes away. Its reference count drops to 1, but it sticks around. That's absolved the factory method from its responsibility. It no longer has to memory manage, right? Its reference count is 0. It doesn't care. The caller then proceeds to use the object and then calls release. And when it calls release, then the object goes away, which is exactly what you want to have happen, right?
Yeah, and it's worth noting that that's how all of those factory methods work. So all those like NS array, array with object, NS string, string with string, all those NS number, number with int, number with all those methods that are on the class specifically, all do alloc, init, auto release.
Right. And if that still seems kind of voodoo-ish to you, the second lab of this for memory management is you're going to get down and dirty and understand this to a great degree, I'm hoping. Where you're gonna mess with reference counts and look at reference counts, build your own auto release pools. They're not that magic, and hopefully it'll be a lot clearer by then. This one you get to play with memory management and you get to play with asteroids. This lab is really fun. Go!